Hello all, welcome to this session. In this session, I'm going to answer one of the Python interview questions. That is, can you explain the concept of object-oriented programming in Python? Let me answer. In order for me to explain the concept of object-oriented programming in Python, I have to explain all these topics along with practical demonstration. That is starting with objects. What are objects and all, then going with classes, then inheritance, okay? Then what is polymorphism, what is encapsulation, what is abstraction. All these things I'm going to cover in a practical way in this session, okay? Along with detailed explanation of each and everything. So let's start with objects, guys, okay? What are objects? So what are objects? So objects are a representation of real world entities, okay? Objects are representation of what? Real world entities in Python programming. In Python programs, if you have to represent real world entities, then we have to use objects or create objects. Okay. In Python programming, in order to represent these real world entities, then we have to create objects. Then a question will come, what are these real world entities and why they need to be represented in Python programming, right? So you need to understand that first so that you will understand objects. So what are these real world entities? Real world entities are nothing but anything that you see in this real world. Okay, what are real world entities? Anything that you see in this real world. I'll give you some examples of whatever we see in this real world. For example, before me there's a laptop. Okay, then I have a mouse with me. I have a table. I have a chair. Okay, I have a water bottle. Okay, I have a mobile phone. I have window, I can see a window, I can see a door. Okay. I can see a switchboard, switches, each and everything that I see in this real world. Okay. Pen, book, paper, anything. Okay. Charger, anything, guys. If I go into the outside my house, okay, even my house is a real world entity. Okay. If I go outside, okay, then on the roads, I see a lot of cars. These cars are real world entities. I see a lot of trees. Trees are real world entities. I see animals. Animals are real world entities. I see trees. Trees are real world entities. You see, whatever we see in this real world are nothing but these real world entities. And to represent such kind of real world entities in Python programming, to make this real world entities part of our Python programming, we have to create objects. So hope guys you understood what exactly are objects now. Objects are simply the representation of this kind of real world entities in Python programming. So we started with objects. Now you got a clarity what exactly objects are. So how to create objects is the next question. Yes, now I understand what are objects. They are representation of the real world entities in Python programming. That's good. But but guys, how to create objects? Okay, but how to create objects? Here is a question. How to create objects? In order to create objects, we need something known as a class. Without class, we cannot create objects. Then what is a class? Class is a template, or you can say, you can call it as a blueprint, or you can also call it as a factory for creating objects. Okay. Using class, we can create objects. Using what we can create objects? Using what we can represent this real world entities, creation of the real world entities in Python programming? Class, guys. Okay. Without the help of class, we cannot create this kind of objects which represent the real world entities in Python programming. We can consider this class as a template or blueprint or factory for creating these objects. Now let me practically demonstrate, okay, how to create a class in Python and using class, how to create these objects to represent the real world entities in Python programming. Let me make this practical, okay? So here in this Python file, I'm going to create a class, guys, okay? I'll use a keyword class here, followed by the name of the class that is car, okay? Here, I name this class as a car. Under this class, car, I'm going to create a template, guys, okay? This class, the purpose of creating this class is to create a template or blueprint using which I can create objects, okay? What does a car contain? Let's say wheels. Every car will have four wheels, okay? The common things I'm providing here. And along with that, I'm going to create some init method, guys, okay? for create any functions, okay, in Python, we have used def keyword followed by the, here init is like a constructor in Java, guys, okay. So in Python, we generally call it as init, and the main purpose of this init method is to initialize the class variables for that particular object, okay. So automatically self will come, okay. I don't want to deviate you guys to self. Self means current instance of this class, okay. That is current object of this class to what we are initializing the variables of the object, right? That is self, okay. Let's not dig deep. So this is how we create a class, guys, okay. So wheels is common, so I'm creating directly under the class, and remaining other things, properties of the class will change from one car to another car. Hence, I'm not creating them as a common variables, rather I'm creating them as a object related variables, okay. Every object, the car properties will change kind of thing. For example, color, or I'll start with the company of the car, okay. Company, then model of the car, then color of the car, then mileage of the car, then price of the car. Like this, a lot of properties will come, a lot of variables will come, but I am sticking to this many. Okay, along with wheels, there are around, you see, 5 plus 1. Wheels is common, guys. Every car has 4 wheels, so I created here. This will change from car to car, so I created here. Okay, init is going to simplify the process of initializing the class variables for each and every object for us. Okay, that's using the self. Self represents the current instance of the current object of the class. Okay, so I'll say self dot company is equal to company. Self dot model is equal to model. Self dot color is equal to color. The current instance of the class, I am, whatever the data that is coming here to initialize, I am initializing them to the current instance of the current object of the class. Okay, like that. Mileage is equal to mileage. Then self dot price is equal to price. Done. After this, guys, wheels is done. Initialize, this constructor is done. Now I'm going to create, you can give some, if you want to give some gaps, right? That's okay. For readability, you can give that, guys. Okay, it's better to give some gaps. And now I'll create some, along with these variables, I'll create some functions. Def, I'll just say def. Here, start car. Start car is one. Start underscore car. Here I'll say print car from company. Which company? Plus self dot company having model. Which model? Plus self dot model has started. Okay, the current instance related data will come here, guys. Okay, whatever the objects we are going to create here, for that current instance object values will come. For every car, this company will be different and this model will be different. Okay, now similarly, I'll create one more function, that is stop car. If I call this function, it will stop the car kind of thing. Okay, so here I'll say print car from company plus self dot company having model, that is self dot model has stopped, like this. Any mistake here? Here, okay. Here this should come, okay. And yeah, car having company, self dot company having model. Which model? That is here. I should not give double quotes. Yeah, has stopped. This is correct. I'll create one more last function, that is car details. One car details function I'm creating. Here I'll print all the details of the car. If this particular function is called, then I'll print all the details of this car. Okay, that is company, model, color, mileage, and price, etc. Okay, so I'll start with the company. Print company of the car is plus self dot company. Okay, then model of the car. Print model. I'm creating the class as a template, guys. You see, I'm proving you that class is nothing but a template. Okay, all this is a part of a template. I'm creating a kind of template. Using this template, I'm going to create objects, guys. Okay, in the next step, I'm going to create objects with the help of this car class template. Okay, so this is an example of a template or blueprint or factory for creating objects, guys. Okay, so model of the car is, okay. Without this example, I cannot explain. Okay, you have to self dot in the interviews also, if you are being asked, okay, about object, class, and all, you have to demonstrate all this stuff. Otherwise, they'll not get it. Okay, they will. Otherwise, they'll not get confidence on you. So model, self dot model, then print color of the car. Color of the car is plus self dot color. Then print mileage of the car is plus self dot mileage. Then finally, price of the car is print price of the car is plus self dot price. That's it. Done. Okay, all the details have printed. If you want to print these wheels also, then I should not be using the self keyword because wheels belong to the class memory, whereas all these things belong to the object memory. Okay, so because they change from object to object, whereas wheels is a common memory or class memory. Okay, so with the help of the class name, I have to access these wheels. Okay, how? Print wheels of the car. Okay, wheels of the number of wheels of the car. Okay, number of wheels of the car is here plus. Here I should not say plus. Okay, here I have to say car dot wheels. Okay, now few things that you have to take care of. Okay, here plus concatenation operator will work with string. That's fine. Okay, but here mileage is in numerical format and there is floating point format. So let's convert that into string, guys. strf. Okay, type 2 typecasting. Otherwise, you are going to get some errors. Okay, here also str of self dot price. Here also str of car dot wheels. Otherwise, this concatenation operator is not going to work. And just for the separation sake, I'll just write this, hyphen symbol. So we are going to create a lot of objects. So when for each and every object, when this particular function is called, all the details will be printed. To segregate the details for each and every object, I'm just writing this. You'll understand that soon. Okay. Now, guys, the preparation of class is done. Okay. As you can see, this class is like a template or blueprint or factory for creating the objects. Now, using this class, I'm going to create objects which represent the real world entities. Okay. So how to create the objects using this class? You say I'm covering these first two topics, guys. These are very important to get started. Later, I'll go with inheritance, polymorphism, encapsulation, and abstraction, the remaining concepts of object-oriented programming. Okay. So coming to the next one, that is, classes. Using classes, I'm going to create objects, guys. Okay. Class is a template or blueprint or factory for creating objects. So I have to take the name of the class, that is car. Okay. And the moment I say circular brackets, the object will be created. Okay. In the computer memory, here, guys, in the computer, let's say this is a computer memory. In the computer memory, an object will be created, guys. The moment you say car, the name of the class followed by circular brackets, you see, it will be created. Some memory will be allocated to this object, guys. Let's say this is object one. And here, what I'm going to do here is, this cannot be empty, guys. Okay, this car, okay, this car object creation statement cannot be empty because this init method has a lot of things like company, model, color, mileage, price, right? I have to pass all these things, okay, from the circular brackets. Company, let's say I'll take one of the car as, I'll take a BMW car, let's say, okay. Company is BMW, model is X series, let's say X series, okay. I'm just taking some random things, okay. Then I'll say, then what is the color of the car is, let's say it is black color. Then mileage is it's going to give 12 kilometers per liter. Then price is around 40 lakhs Indian rupees. And wheels I don't have to give because for every car 4 wheels will be there. Okay, I don't have to pass it. Okay, now object is created. So the moment I say like this data will go into the init method will be automatically called. Okay, and BMW will go into company. BMW of this particular object. Okay, here this is object creation statement, guys. Using the class, I'm creating an object, guys, and for that particular object, this is the data. Okay, we have to initialize the class. Instance variables of this class. Okay, for that particular object, we have to initialize all these class variables. So BMW will go into this company. Okay, for the current instance, model X series will go into model. Color will go into current instance of the class like color. That is black color will go there. Mileage 12 kilometers per liter will go 40 lakhs rupees will go here. Price in Indian rupees like that. Okay. So in the object memory, so here company is equal to BMW, model is equal to X series. Then what is the next one? Color. Color is equal to, how to give small company, small model. Color is equal to black color. Then mileage is equal to 12 kilometers per liter. Then price is equal to 40 lakhs in Indian rupees. And then what is there? That's it, right? That's it. Okay. All these details will be stored here. And to refer to this, you see every memory slot that is allocated for this object will have some numbers like this. Okay. No one can remember this memory address where this object is created. Okay. To refer to this, we have to use object reference case. Okay. Here I'll create an object reference. I'll create an object reference which refers to this object created in this statement. Okay. What is the object reference? For example, BMWX. Okay. BMWX is the object reference. Now, so here the object reference to refer to this, because we cannot remember all these numbers, right? BMWX is the object reference like that. Now, if I have to, using this object reference, I can access these functions. Okay. I can access all these functions and variables of this class. That's okay. So I can call like this BMW X dot start car, BMW X dot stop car. One object. I created one object. You see, I'm playing with the, I have implemented real world entities already. Okay, this BMW car is a real world entity. Okay. In Python programming, I implemented real world entities in the form of objects. Okay. Objects are the representation of real world entities in Python programming. But for creating the objects, we need the class template here. Okay. So car is the class template. Okay. Using which we created the object. And objects are represented. Real world entities are represented in the form of objects. Okay. Objects are created with the help of class. That's it. Okay. Hope you are getting the idea. Then car details. Okay. If I run this code, okay, all these three functions will be called where car from company, that is BMW having model X series has started. When this particular function is called, car from company, BMW having model, which model X series has stopped, will be printed. When I call this car details using this object reference, then company of the car is BMW, model of the car is X series, color of the car is black, mileage of the car is 12, price of the car is 40 lakhs, number of wheels of the car is, from here it will come 4. Okay. For every car, wheels is common. Okay. Run this. Let's get all these details printed. You see, whatever I said has come in the output. Now, can I create only one object? No. As I already mentioned, class is a template or blueprint for creating objects. I can create any number of objects. Let's say I'll create few more objects. That is, I'll create one more thing. And here I'll mention Honda is a company and Amaze is a model. Then gray color, then 14 kilometers per liter. Let's say it's the cost is around 9 lakhs in Indian rupees. Okay, all this I'll create. Here I'll say Honda is equal to, or I'll give a short form like this, HAMZ. Okay. So what happens here is, here the moment I say car of something and pass all this data, right? What happens here is, for object 2, memory will be allocated. Object 2 will be created in the Python, and here it will have some other address. That's okay. So here company is equal to Honda, and model is equal to Amaze, color is equal to gray, mileage is equal to 14, price is equal to 9 lakhs in Indian rupees. Okay, like this it will be created. And for this also, to refer to this object memory, we cannot remember the memory address, right? So some object reference is required. That is nothing but HAMZ is the object reference. Now, I'll say HAMZ dot start car. Honda Amaze car will start. Stop car. HAMZ dot print car details. Okay, you see, now I run this, you'll get the details of 2 cars. Okay, this is one car that is BMW related. This is, you see, Honda Amaze gray 14 9 lakhs and 4. Okay, so this is how, guys, we need to understand about objects and classes in Python. This is how this is a proper explanation, guys, of object-oriented programming in Python in terms of objects and classes. But object-oriented programming is not restricted just to objects and classes, but we have few other things like inheritance, polymorphism, encapsulation, and abstraction that I'm going to cover now. Okay, let's go with the next topic now. That is inheritance. What is inheritance? What is inheritance? Inheritance is a mechanism in which one class acquires the properties of another class. That is, a child class acquires the properties of the parent class. Okay, inheritance is a mechanism in which a class acquires, okay, the properties of another class. Okay, so why a class need to acquire the properties of another class? Okay, so generally, guys, okay, let's not go deep into that for now. Okay, you see, in real world, we have our parents and we inherit the genes, properties, and everything from our parents. Okay, our children will inherit the things from us, right? This is what is inheritance in real world. Okay, here also a class can, in Python also, a class can acquire the properties of another class, guys. But why? Why in programming a class need to acquire the properties of another class? The reason here is, for example, in what happens in general is that you will be creating multiple classes, guys. Let's say HDFC Bank, Axis Bank, ICICI Bank, Canara Bank, or whatever it is. Okay, different banks you created, and all these banks have the same variables and methods. Okay, same variables having the same name and methods. Okay, that means you are duplicating the code here. So if multiple classes have the same variables and methods, that is a duplication of the code. Okay, you are not reusing the code, rather you are duplicating the code, which is not a good idea in programming. In such cases, what we do is, so we create one parent class. For all these classes, we'll create one parent class, okay, which contains all these common variables and properties. Okay, which contains all these common variables and properties, and you don't have to create these variables and functions which are common across all these classes again in individual classes, because we have a parent class here. All these child classes are going to inherit these common properties from the parent class. This is the main purpose why we have to implement inheritance in Python programming language. Inheritance is a mechanism in which a class acquires the properties of another class, guys. Okay, that's what is inheritance is. Okay, so what is the syntax and all? How a class can acquire the properties of how to make a particular class a child class of another class which is going to the parent. Okay, there are different terminologies here, guys. The class which is going to acquire the properties of another class is called as child class, and from which class we are going to acquire, that is called as a parent class. Okay, we can also call this child as a subclass. Okay, here we can superclass, uh, then derived class. Okay, derived class, we can say this is we can call it as base class. Parent or super or base, anything is same. Child, sub, or derived is also same. Okay, so let's not go with the difficult terminology for now. So child and parent I'll choose. Okay, a class which is acquiring the properties for another class is called child class. The class from which the properties are getting acquired by the child class is called as a parent class. Okay, so how to make a class acquire the properties of another class, I'm going to demonstrate now. So here, guys, I'll remove all this code. And I'll create a class. Let's say I'll simply, just for the sake, I'll create a class A, guys. I can take more realistic examples, but just to save time, I'm taking the simple things. Class A, I'll say, okay, class A. And here, I'll say A is equal to 9 and say def. I'll create a function also. I'll create a function inside the class, def. I'll say sample underscore A, okay, like this. Now here I'll say print inside sample underscore A function of class A. Like this, I'll print out. Okay, if this particular function is called, this will be printed out. Okay, now I'll create one more class. I want to make this class a child class of this class A. These properties of this class A need to be inherited by this. Okay, I should not be created. If I have to create this A and sample A in the B class, I will not going to do that, because I'm going to make the class B a child class of the class A. So it's not required for me to create this variable and function again under this class B. So what I'm going to do here is, instead of creating this, this class B has its own properties, guys. But apart from that, the class B has to inherit the properties of the class A also, instead of recreating them again under the class. So here, beside the class B, which I want to make it as a child class of the class A, I have to put circular brackets, and inside the circular brackets, I have to put A. This means that class B is now the child class of the class A. Okay, like this. Now, class B can have its own properties. Let's say B is equal to 5, then def sample underscore B. Okay, here I'll say print inside sample underscore B function of class B. Like this I'll create. Okay. Now I have to create. Let's create an object for the class B, guys. Okay. If I create an object for the class B, not only the properties of the class B can be accessed using the object reference of the class B, rather the inherited properties from the class A, which are inherited by the child class B, also can be accessed. I'll show you now. Okay. So here I'm going to create an object for the class B. B circular brackets will create an object. I don't have to pass anything because we don't have any init method or something. So I don't have to pass anything. So here I'll say obj object is equal to, okay, object for B, guys. Okay, obj B. Obj means object of the class B, let's say. So using this object reference, I can access not only the properties of the class B, since class B is a child class of the class A, these properties will be inherited by class B. So all these properties, 4 properties can be accessed using the object reference of the class B, guys. Okay. Obj B, I'll say simply print of obj B object B dot, you see, I can access A. A is from the class A, but I created object for the class B. Still I can access because this property is inherited by the class B. That's what is inheritance all about. Print objb dot, I can access the properties of the class B also. Okay, apart from the inherited properties, I can access the properties of the class B also using the object reference of the class B. Obj, here I want to access the functions. Okay, the function from the class A I want to access using the object reference of the class B. Okay, that is I'll say objb dot sample A. Inherited function will be called objb dot sample B. The class B specific function will be called. You see, all the things will happen, guys, without any errors. You see, 9 got printed, 5 got printed, insert sample A function of class A got printed, insert sample B function of class B. This is what is inheritance, guys. Okay, this is a concept of inheritance where one class inherits the properties of another class in Python. Okay, that is all the properties I don't have to mention A is equal to 9 again and def sample A again in the class B. Okay, these properties are automatically inherited by the class B because I'm making the class B a child class of the class A with this syntax. So this is what is inheritance, guys. Okay, is a mechanism in which one class acquires the properties of another class. Okay, there are different types of inheritance, but I'm not going to cover in this topic because if I keep on doing that, it will be very lengthy session. Okay, a lengthy answer. Okay, let's stick to inheritance. Okay, I'll be covering the types of inheritance in another interview question. Okay, then polymorphism. Next inheritance concept we have is polymorphism, guys. First of all, what is polymorphism means? What is polymorphism means? Poly means, first of all, the meaning of poly is many. Morphism means poly means many, morphism means forms, many forms. Having a single name, it can do multiple things. Okay, name is same. Okay, let's say there is a function, but it can do multiple things. That is morphism. Single name, but many forms. How that is possible in Python? Polymorphism in any programming language, not only Python, is possible in the form of overloading and overriding. Okay, these are means. Okay, polymorphism in Python and any other programming language is possible in the form of overloading and overloading, guys. Under polymorphism, we have overloading and overriding. Okay, poly means many and morphism means forms. Let me demonstrate this polymorphism for you now. So let's go with this parent and child classes. Let's go with the same parent and child classes. So here for overriding, guys. Okay, first I'll go with the overriding, second one of this polymorphism. You see, what I will do is I'll just in the parent class we have A is equal to 9. In the child class we have def sample A. I'll create the same variables and same functions inside the class B also, which is the child class of the class A. Here B is a child class of the class A. I'm going to create the same variable. You see, in B also we have the same here, but A is equal to 5. I'm saying here def sample. Here also I'll create the same function, sample A function. Here I'll say print inside sample A function of class B, I will say. Okay, like this I'll create. Now, if I create an object for the class B, and give some object reference to that, objb like that. Now, using the object reference, if I access this A and if I access this sample A, inherited variables and functions will be called, or the child class specific functions will be called. You see, because the child class variable has the same variable name as the class A, parent class variable. Okay, the child class function has the same name as a parent class function. In that case, there's an ambiguity, right? Because class B, which is the child class of the class A, inherits the properties of the class A, and also it has its own properties, okay, having the same name. Then in that case, obj will take this inherited properties or give importance to the child class specific properties. That is the question. Okay, that is the question. So here, in case of overriding, guys, one of the concept in polymorphism, via which polymorphism is possible in Python, that is overriding. What happens is the class B properties are said to override the properties of the class A. If the class B, that is the child class properties, are matching with the parent class properties, in that case, the child class properties are said to override the properties of the parent class. That means they are going to replace. Okay, but if the child class properties are not matching with the parent class, no problem. Okay, then that is a different story. But in this case, the child class properties are matching. The names and names of this child class properties are matching with the parent class properties. In that case, the child class properties are said to override the properties of the parent class. That is, replace the properties of the parent class. So if I say print obj b dot a, so what will be printed? 5 will be printed or 9 will be printed? As I already mentioned, the child class properties will be printed. That is, 5 will be printed. Okay, not 9 will not be printed. Overridden means replacing. Okay. Similarly, the sample A is going to replace the sample A of the A class. So if I say obj b dot sample A, here this function will be called, not this function. Okay. So run this code, you will understand. Okay. You see, 5 got printed instead of 9 didn't got printed because this variable A is overriding this variable A of the parent class. Okay. So inside sample A function of class B, it is saying, you see, from here it got, this one got printed. If this all got printed, class A got printed. Okay, class A would have printed. Okay, now inside sample A function of class B got printed, guys. Fine. So this is called as overriding, guys. Okay, here poly means many forms. That is, with the same name, we have same name. Here we have a variable with the same name. Here also we have the variable having the same name. Here also we have the function with the same name. Here also we have the function with the same name. And poly means many forms, same name having multiple forms. Okay, like that. Okay, so another way is overloading, guys. Overloading is not directly possible in Python, guys. Okay, in Java it is directly possible, but in Python overloading is not directly possible. Okay, as part of polymorphism, here overloading is there also in Python, but it's not directly possible. Indirectly we have to do it something. Okay, so what I mean is, here I'll go with only one class, let's say class A, and here I'll create one function. Okay, here I'll create one function, let's say sample function. I'll say sample A function. And here under this sample A function, I'll say print of inside sample under A function. Okay, inside sample underscore A. Similarly, inside the same class, I'm going to create a duplicate function. Will Python allow you to create duplicate function inside the same class? Yes, it is going to allow without any problem. Unlike other programming languages, Python programming language allows you to create the same function inside the same class. Duplicate function error is not going to come for us. Okay, it's the same function I'm going to create, guys. Sample A. Okay, print inside sample underscore A2. Okay, like this I'll create. Now, what is coming here? Redeclared sample A above without usage. Okay, so something is coming, that's okay. Let's create an object for the class A and give some object reference obj. Let's see what's happening with this. So obj A dot sample A, if I call and run this code, what is getting printed? I'm not getting any error, guys. Rather, you see, this function is ignored. You see, both functions are having the same name, but the latest function will be, okay, in Python, even though there are duplicate functions in the same class, the older functions having the same name will be ignored by Python, okay, which is not same in other programming languages. Okay, in Python, the latest function having the duplicate name will be considered. Okay, older function names having the same name will be ignored. No matter if they have the same parameters, different parameters, doesn't matter, guys. Okay, doesn't matter. That doesn't matter for us. So, but I want a situation where a single function has to do different things. Okay, when I call it differently, that is generally possible in Java directly, but in Python that's not possible, guys. For that, I'm going to create a function. I'll explain that. What I'm going to do, I'm going to explain that. Def sample underscore A. Here I'll say comma A comma B. I'll say, okay, A comma B. I'm going to, you see, I want this particular function to be called without passing any arguments. I want to call this function to be called only passing one of the arguments for these parameters. That is, though it has two parameters, I'm going to pass only one argument, or in some cases I don't want to pass any arguments, zero parameters. Okay, should work like that. Okay, how to program that? Okay, this is the only way, guys. Okay, a is equal to, by default, if I don't pass anything, a should be considered as none, and if I don't pass any argument to b should be considered as none. Okay, now I'll create a logic here. If a is not equal to null and b is not equal to none, means that means you have passed two arguments for two of these parameters. In that case, what you have to do? I'll say print a plus b. I'll say, okay, I'll calculate the sum of these two values. Okay, then else instead of else, I'll say elif. I'll say a is not equal to none. One of the parameter is not equal to none. Okay, other one is none only. Okay, another one is not passed. In that case, print of a I'll print. That's it. Okay, whatever the value that is passed, right, that I am going to print. And finally, else, if both are not passed, in that case, I'll simply print. Okay, nothing to print else. Okay, so like this, I'll create a kind of function, okay, which can perform a lot of operations. Okay, different based on the number of parameters arguments I'm going to pass to these parameters. Based on that, this function is going to do different activities for me. Okay, just see here what I'm going to do. I already created an object for the class A like this, and using the object A, if I'm calling this sample A like this, I'm not passing any arguments. In that case, what will happen? A will be considered as none and B will be considered as none because I'm not passing anything. And here this condition will be false, this condition will be false. So else block will be executed, nothing to print will be printed. Now if I say obj A dot sample, if I pass some value 9. So in this case, A is not none. So this condition will be passed and it will print 9. Okay. If I pass obj A dot sample underscore A, I'll pass two values. That is, I'll pass 8 and then I'll pass 7. Okay. 7 plus 8, that is around 15. 15 will be calculated here and printed. Okay. So this same function is going to do different activities based on the number of arguments I'm going to pass. This is how indirectly, by using a logical way, the polymorphism way of overloading is possible in Python. But directly it is not possible, guys. Okay, run this. You see, first sample A, nothing to print. Sample A only 9, only exact 9 got printed. Okay, 8 plus 7, 15 got printed. Okay, so same function is performing different activities for us. So indirectly, overloading is possible in Python. Okay, overloading is indirectly possible in Python, guys. It's not directly possible in Python. So we are done with polymorphism. Also, we are left out with two more object-oriented programming concepts in Python, that is encapsulation and abstraction. Okay, let me cover the encapsulation now. So encapsulation means, so I'll create a class, let's say class A, guys. Okay, simple class A. I'll make some variables private. Okay, I'll just make a variable private, guys. Okay, that is I'll make this particular variable private. Underscore A is equal to 9. I'll say. Okay, that means you cannot access this variable outside this class. This variable is private. The moment you provide underscore A, this variable is going to become a private and you cannot access this variable outside the class. Similarly, you can make a function also private, or doesn't matter. Okay. So here I'm going to talk about encapsulation, guys, where if one of the variable is private and if I have to access this particular variable, if I want to access means I want to update the value of this variable or I want to get the current value of the variable outside the class, it's not possible, right? So for example, here under the class, we have this variable created, private variable. Now, if I create an object for the class and say obj A is equal to A like that, and now if I say print of, this is a class variable, so I can directly say I don't have to create object also, but let's see obj A dot underscore A, which is not possible, guys. You see, you cannot access it. Okay, you cannot access it. Run this. It will give an error saying that okay, no attribute is there because it is private, guys. You cannot access this particular private variable of this class outside the class. This is not possible. Then how to update the value of this variable? How to work on this variable from outside the class? Okay. For example, guys, simple words encapsulation is something like this. Okay, encapsulation is something like this. In real world example, encapsulation. Let's say you have a car. Okay, you bought a car. I'll just draw a car here. Let's say this is a car. Let's assume that. Okay. So these are the wheels of the car. Okay. So now you bought this car and you are the owner of this car. You have got a key. Okay. You have a key Using this key only, you can open the car, right? You can start the car and all those stuff. But other people should not be able to interfere with this car. Okay, they are not the owners of this car, so they should not have this key. Only the one who has a key should be able to use the features of the car or whatever it is, use the car otherwise. Okay. Similarly, here, private is something which is private to this class, but there may be some situations where I want someone having that key kind of thing should be able to access this variable of the class, that is update the variable or access the current value of the variable or whatever it is from outside the class. Only few should be given the permissions who are kind of owner kind of people should be given the permissions. Not everyone. This is like everyone, okay, which is not possible. So what we are going to do here is, along with this variable, private variable, we are going to create some getter and setter methods, okay? To make this encapsulation possible, we have to create some getter and setter methods, okay? We are binding the data to this class and we'll only make this private variable accessible outside the class with the help of functions, guys, okay? Binding this data to the functions kind of thing, okay? So that is called as encapsulation, guys, okay? Encapsulation. Only the ones who have access to this functions of this class should be able to access these variables. In simple terms, that is called as encapsulation, guys. Binding the data to the class, okay? And access to this data of this class should be only possible with the help of this getter and setter methods. That is encapsulation, okay? So fine. So here I'll create def. I'll first say set the value of a. How to set the value of a? I have to pass some a or something. I'll say underscore a is equal to a, I'll say, okay? Underscore a is equal to a, I'll say, okay? Fine. Like this. This is how I can set it, okay? This is not private, guys. This function is not private. So if I add underscore, it will become private. I cannot access it outside the class, okay? But if I don't give underscore, it's not private. Again, to get the value of current value of a, I have to say get a outside the class if I have to get it. Even though it is private, I can access this variable outside the class with the help of these functions, okay? Only the ones who have the access to this function can access this variable kind of thing, okay? Here, I'll say print a, that's it, okay? Print underscore a otherwise, okay? So here I cannot say underscore a because I have to use self keyword, self dot underscore a, the error will be gone. Here also I can say self dot underscore, yeah, let's see. That's working fine. So here, so if I have to access this variable outside the class using the object reference, what I'm going to do is first I'm going to say obj a dot set underscore a up. I want to set this value 9 to some other value. Let's say 19 I want to set. Okay, I want to set it to 19, guys. And after setting it to 19, then I want to call this, okay? So that obj a dot get of a, the latest value 19 will be printed. Before updating this value to 19, I'll just print it. The original value of a should come, that is get of a dot get of a. It will print 9, then it got updated to 19. Here it will print 19. Run this. So you say initially 9, then after updating using the set, we got 19. Even though it is a private variable, we are able to access it with the help of this getter and setter methods. This is how we can bind the data to the class in the using which encapsulation is possible. And the ones who have the access to this particular private variable of this class can modify this value or get the current value of this private variable of this class with the help of getter and setter methods. This is what is encapsulation in simple terms. Now, last object-oriented programming concept in Python is abstraction, guys. Abstraction means partial implementation. What is abstraction? Abstraction means partial implementation. Okay, abstraction means partial implementation, guys. Okay, partial implementation means let's say a particular class is there. That particular class, okay. So particular class don't have to implement all the functions. Okay, the child classes of the classes can implement those unimplemented functions of the parent class. Okay, that is the classes which contains the just defined functions which doesn't have the code, implemented code under the functions are abstract functions. Okay, and the class having such kind of abstract functions is called as abstract classes. Abstract classes are all about partial implementation. I'll show you practically here. I'll simply say class A. Okay, I want to make this class A an abstract class. How to do that? So for making this class A an abstract class, I'll give you something, guys. Okay, first of all, I have to make this class which is going to become an abstract class, a child class of ABC, guys. Okay, hold the mouse on ABC, import ABC from ABC module kind of thing. Okay, from ABC module we're importing the ABC class. Okay, this is a kind of inbuilt class in Python, guys. Okay, if you want to make a particular class an abstract class, you have to make this abstract this class a child class of the predefined or inbuilt ABC class of Python. Okay, that's one thing. And since this is going to be an abstract class, not all functions need to be implemented, guys. I'll create some functions. Let's say sample one function I'll create. Here I'll implement this. Okay, I'll write the code. I'll write some print statement as sample. Okay, this particular function has implementation. It's not an abstract function. Okay, inside sample one. Okay, like this. Now I'll create one more function. This function I don't want to implement, guys. Okay, def sample two. I don't want to write any code under this. Okay, so here I'll say self, and here I don't want to write any code under this. Okay, only declaration is required, definition is required, but implementation is not be there. So just to instead of keeping it blank, I'll just mention pass, guys. That means nothing. Pass is nothing, guys. Okay, just instead of keeping it blank, we'll generally provide a pass in Python. And here on the top of this, we have to provide an annotation known as abstract method annotation. Okay, hold the mouse on abstract method, import this abstract method from ABC. This particular module, we have to import this abstract method annotation from. Okay, like this, guys. This method is not implemented, guys. You see this particular class is an abstract class because one of the function is implemented in this class, another function is not implemented in this class. Okay, so who will implement this function of this particular class? The child class of this class has to implement. Okay, so I'll create one more class, that is class B. In Python, the child classes will implement the functions of the unimplemented functions of the parent classes. Here A is going to become a parent of this B. So in this case, what happens is have to make this since B is a child of this A, the B has to implement the unimplemented functions of the class A. So here I have to write def sample 2, and here I'll implement it. Okay, I have to implement it here inside sample 2. Okay, like this. Now since it is implemented, now I cannot create an object for the abstract classes in Python. It is not possible to create an object for the abstract classes. You cannot create an object for the abstract classes. But to access these properties of the abstract class, we already have created the child class. We are going to create the object for the child class, and using the object reference of the child class, we are going to access the properties of both A and B. That is, A is in, this function is implemented, right? That will be inherited by the child class, and using the object reference of the child class, both will be accessible. Okay, that means here I'm going to create an object for the child class. Here I'll say obj B is equal to, and using the object reference of the child class, I can call sample1 and sample2 functions. You see, sample1 is which is already implemented in the parent class. I mean, parent abstract class also is being called, and sample2 function, which is an abstract method in the parent class, is implemented in the child class. Need to be implemented by child class, right? Otherwise, child class also will become abstract, and we need to create one more child class for this child class. Okay, so that's what is the thing. Now run this code. You see, you'll be able to access inside sample1, inside sample2. Okay, so this is called as abstraction, guys, where the classes will have partial implementation. Few functions of this class will have implementation. Few function of this class will not have implementation. Those are called as abstract classes. And the child class need to implement the unimplemented functions of the parent class. Okay. So hope guys you understood all the concepts of object-oriented programming in Python in this session. It's a very detailed session, I know. So if you come across this kind of question, take that as an advantage and explain all this stuff. Okay. So that the interviewer get a confidence that you know everything, that every object-oriented concept of Python, you know, the interviewer will get a confidence. Okay. So that's all for this session, guys. See you in the next session where I'm going to answer another Python interview question for you. Till then, see you. Bye-bye.